All right, what if we want to transform a polar equation to a rectangular equation, or transform a rectangular equation to a polar equation? All right, let's start with a polar to a rectangular first. So let's say we are given the polar equation, r is equal to 6 cosine theta. And instead of a polar equation, we want to make that a rectangular equation. So r equals 6 cosine theta. So we can graph that in polar form, but we can also convert it to rectangular form to graph it, and they would make the same graph. So there are two common ways to convert from polar to rectangular. One option is you can multiply both sides of the equation by r, or another option that you could try is you could try to square both sides of an equation. Well, let's try multiplying both sides of the equation by r first. So let's multiply both sides by r, and we would get r squared equals 6r cosine theta. Now remember, when we were converting from rectangular to polar or polar to rectangular coordinates, we used the two equations, r squared equals x squared plus y squared, and then we had tangent theta equals y over x, so we used that set. And we used x is equal to r cosine theta and y is equal to r sine theta. So we used those two pieces of information to convert from rectangular to polar or polar to rectangular. Well, let's see what we got. Right now we're in polar form because we have thetas and r's, but can we substitute? Well, we have an r squared. What is r squared equal to? R squared is equal to x squared plus y squared. So this is going to be substituted to x squared plus y squared. And then on the next side, we have 6r cosine theta. Well, notice that r cosine theta, I can replace that with x. So instead of 6r cosine theta, we can rewrite this as 6x. And so now I have x squared plus y squared equals 6x. Well, unfortunately, now we are going to have to go back to our old idea of completing the square to make this into a graph that we can recognize. So this is way back, I think back in unit 1 we did this. So I'm going to get all of my terms on the same side. So x squared minus 6x plus y squared equals 0. So I'm going to subtract that 6x to both sides. And then if you remember, what we did from here is we completed the square for the x term and the y term. So remember, to complete the square, you take b, you divide by 2, and you square your answer. So you take the b term, divide by 2, and square the answer. So we're going to take negative 6, we're going to divide by 2 and square my answer. So negative 3 squared, that's going to be 9. So to complete the square, I'm going to add 9 to the left side. Whatever you do to the left side, do to the right side. So I'm going to add 9 to both sides. And then I factor. X squared minus 6x plus 9 factors into x minus 3 squared. And then we have plus y squared equals 9. Do you recognize what this is? Well, it's a circle whose center is at 3, 0, and whose radius is 3. Because remember, circles are x squared plus y squared equals r squared. That's the equation for a circle. So it's a circle whose center is at 3, 0, and whose radius is 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And so that would be the rectangular graph, or the graph on rectangular with rectangular coordinates. But we can also do this in polar. So on Desmos will let you graph in both rectangular and polar form. So let's graph that in rectangular form first, and then I'll show you that they're the same graph. So x minus 3 squared plus y squared equals 9. Or if you wanted to, Desmos would also graph that first example, x squared plus y squared equals 6x. So Desmos will graph it without you having to rewrite it. So again, if I took that off or put it back on, it's the same exact thing. Well, Desmos will also graph that original graph, r equals 6 cosine theta. So if you hit the little wrench button and you change your grid, so notice on the right under off it says grid, and you have the green right now looks like rectangular. If you hit the one that looks like a spider web, now we're in polar form. So if you go back to the graph, notice we're in polar form. And so it'll keep that graph, the original graph that we had of the circle. But if I did this, and so we're going to do r equals, so r equals, and then cosine, and then we're going to go to the ABC, and then you have a theta button. It's right next to L underneath the P. And then notice we've got, oops, it's 6 cosine. And notice it's the exact same graph. So r equals 6 cosine theta is the same as the x minus 3 squared plus y squared equals 9, or the x squared plus y squared equals 6x. So if I take the blue graph and the red graph off, notice I have the green graph, or if I take the green graph and put it on, it sits over all of the other graphs. So they're all the same, whether you're in rectangular or polar. All right, what if we want to go from rectangular to polar? So we have 4xy equals 9. So if you want to go from rectangular to polar, remember we have r squared equals x squared plus y squared. We have tangent theta equals y over x. And then we've got the x equals r cosine theta and y equals r sine theta. So those are the equations that we can use. So we're starting with 4xy equals 9. So 4xy equals 9. Well, we can substitute in for both the x and the y. X, I can substitute in r cosine theta for x, and then for y, I can substitute in r sine theta. So this equation would become 4 times r cosine theta times y, which is r sine theta, and that's going to equal 9. So now I have 4, r times r is r squared, so 4r squared equals cosine theta sine theta, which equals 9. I could divide both sides by 4, or technically I'm in polar form right now because I have cosines, sines, and r's. So we're technically done at that point. Or we could solve for r. So I'm going to divide both sides by 4, and I get r squared cosine theta sine theta equals 9/4. And again, we're technically in polar form right now, so let's see if the two graphs would match up on Desmos. So let's start in rectangular form. So let's switch our graph back to rectangular form. And we're just going to type in 4xy equals 9. And so it looks like a hyperbola. And so if I were to graph, we'll just do this guy right here, r squared. So let's switch to polar. And we're going to graph r squared. And then we have cosine theta, sine theta. Sine theta equals 9/4, so 9 divided by 4. Oops. What do we need? Polar equations must be, linear. Okay, so Desmos doesn't want us to graph, so we're going to have to get r by itself. So we're going to solve for r. So r squared, we're going to divide both sides by cosine theta, sine theta. So we get r squared equals 9/4 sine theta cosine theta. And then take the square root of both sides. And so r is going to equal plus or minus the square root of 9/4 sine theta cosine theta. Let's see if it likes that better. So r equals, we're going to do the square root of 9 divided by, and then we have 4, and then let's see if it will let me do sine theta cosine theta, sine theta cosine theta. And there we go. It does. So we have r equals the square root of 9/4 sine theta cosine theta. So on Desmos, you're going to have to solve for the r. I don't know if your book is going to make you solve for the r or not. If we are back up at this point right here, so we had 4r squared sine theta cosine theta. So cosine theta sine theta equals 9. You also have a way to simplify this so it looks a little bit nicer. Remember that sine 2 theta was equal to 2 sine theta cosine theta. So if you wanted to, you could rewrite this. This 4 could become a 2 times r squared, then times 2 cosine theta sine theta equals 9. And you can replace that 2 cosine theta sine theta with sine 2 theta. So we would have 2r squared sine 2 theta equals 9. Makes it look a little bit cleaner, but again, you don't have to. So I think on your book, they let you leave it as r squared cosine theta sine theta equals 9/4. But we'll talk more about that in class. All right, so your homework is from 9.1. Let me know if you have any questions.